our last talk. Bagrada bug, what do we really know about this new pest? Be presented by Dr. John Palumbo. John is a professor of entomology and extension specialist in the Department of Entomology at the University of Arizona. Certainly no stranger to us here in this dusty little desert town and really across California as well. John received his bachelor and master's degrees in entomology from the University of Arizona and received his PhD degree in entomology from Oklahoma State University. And Dr. Palumbo conducts research and extension programs developing IPM strategies for insect pests and vegetable crops at the Yuma Agricultural Center in Yuma, where he has been located since 1990. He's also served as a state IPM coordinator from 1997 to 2003 and currently serves as our state IR4 liaison.
I gave a presentation at this breakout session last year at the same time. Bagrada was really a new pest for us. And I'm kind of going to start this presentation as a transition from what we saw last year at this time to where we're at now. For those of you that aren't familiar with Bagrada, which I think most people in the desert are, just give you a real brief update because I want to talk about some real specific things that addresses the title of my talk. What do we really know about this pest? It was first detected in 2008, Orange County. Not sure where it came from, probably some container ship from somewhere. But it was really 2009. It was first found over in Coachella. Shortly thereafter, we found it here in Yuma damaging crops. And then, of course, we went through that issue last year trying to figure out what we were dealing with. It reappeared in much heavier numbers last fall, 2010, not just here, up the river, central Arizona, those guys were dealing with it as well. So obviously the pest had spread from that first reintroduction. A little bit of background, it is indigenous to the old world. Africa, India, it's debatable which one of those countries it's from, but again, you look at what literature is available on this pest, those environments are very similar to our environments. Warm, and they grow a lot of coal crops. And as I'll show you, most of you know that's its preferred host. It's a small stink bug. It's a stink bug. The penatomic family, this is just a real classic image of it. This is it relative to probably the most common stink bug that we have in the Yuma area anyway, the say stink bug, which you typically find on just about everything we grow. It's about a third of the size of a say stink bug. But relative to the say stink bug, it's much more damaging. And that's really what I want to talk about this afternoon. And I'm going to go at a fairly rapid pace because I want to cover quite a bit of ground. And I want to cover these three areas, to me, are the big gaps in information. A little bit of information I think we know, and then there's stuff that I don't think we know. When I say we, I'm mainly meaning me, but maybe collectively as well. Population biology and ecology, damage potential, and then of course IPM or control. And this is the areas I want to cover. And I want to start with this population ecology. And I think we all have a pretty good sense of its in-season activity, its dial activity, and I'll explain to you what I mean by that in a second, as well as its crop preferences. But there's this area over here that, to me, is a big question mark, which may be real critical in the long-term management of this pest. So I want to start in this area first. This is some data that we collected starting this year, starting in early September. This is all in untreated coal crops on an experiment station, small 1 or 2 acre blocks. You can see the wet dates and the crops that we've been tracking them from September 6th all the way until just this week. And what you'll notice, what really strikes out, is that they were very, very active in pretty significant numbers October, going into November, and then certainly in the last couple months, their numbers have been almost non-detectable. They're there. I can take you to the farm and show you some canola, and I can show you some as. But in terms of big blocks of production, relatively production type stuff, you're not going to find it. What's interesting is that it all equates to temperatures. If you track temperatures and you track development, it's very similar, or population activity. So again, it's driven by temperatures. It's a warm season insect, like many of the plant bugs that we deal with. This is just a quick summary, just to kind of give you by month. This is summed across all the crops that we sampled during that period. And again, you can see temperature drops, so do similarly the populations. Just a quick summary. This is dial activity. What I mean by dial activity is it's day and night activity. And I wanted to do this study and look at this thing, what its behavior was during the day and at night as well, because some stink bugs are more active at night than they are at day on some crops. And so what we did, this is 4 o'clock in the morning, 7 o'clock in the morning, 10 o'clock in the morning, so on and so forth. Here's day 2 at 4:30 in the morning, 7 in the morning, 1 o'clock in the afternoon. And if you look at this without having to pay a lot of attention to it, what you see is that early in the morning, at the coolest part of the day, they're very, very difficult to find on the plant. You can't hardly find them. At the warmest part of the day, when the temperature's peaking out in September, you can see they're very active.
Are they down near the ground?
A lot of times, well, sometimes they're on the ground, sometimes they're in the cracks in the soil. Just depends. This time of the day, they're almost always on the plant. Can hardly ever find them. This time of the day, we find a lot of them on the ground. And probably because the soil temperature is warmer. The cracks in the soil are probably warmer than the plant or the soil surface. But again, this goes back to sampling. When do you look for them? Well, if you look for them at this time of the day, when everybody wants to beat the heat, get out and look at those crops early first thing in the morning in September, 4, anywhere about 6:30, 7, 8, you might miss them. You get out there in the hottest part of the day, and chances are you better chance of actually seeing them.
So it's not sunlight, it is temperature.
It appears to be temperature. It sure does. Okay, does everybody follow that? I mean, it seems like they're very hard to find the coolest part of the day. And I think, again, a lot of times they'll go into the cracks in the soil. That's what I think I know about their daily behavior. If you look at their host range, and I call this the exotic host range because this comes out of literature out of India and Africa. And it's not the most reliable source of information because much of it's not based on any kind of scientific work. All the cruciferous crops, the brassicas, the cold crops are listed here. Here's a number of agronomic crops, many of them we don't even grow in this area. And then you've got a whole list of weeds. And last year we were looking at this saying, okay, we got to pay attention to this. And this is important because this is where they're going to be in about 2 months, presumably, when there's no more cold crops being grown, seed crops or what have you. Fortunately, I've been teaming up with some guys out of University of California, Riverside, Tom Perring and Darcy Reed. I've been on a collaborative project, and they're actually in the lab growing plants, placing adult Bagrada on these plants and trying to determine if there's a feeding preference for these individual hosts. They've got to categorize as high or heavy feeding damage and wilting, looks like you can see on the cold crop. And as you can see there's all the crops we grow, and there's all our winter mustard type crops that we grow. They can actually find them really feeding very, very vigorously on those plants. The non-brassicas that they have found this high feeding response on are mainly grasses. Corn, Sudan, that's a big one for us. Oats, barley, rye. They haven't tested wheat. My guess is it's going to fall right in line here. Then they've got this no preference, whereas in a captured cage, if you will, there's no feeding observed. And that's a lot of crops that we grow, some of them that we don't, but a lot of them that exist. Some of them were on those lists, that exotic host range, as were some of the seeds. So we can't completely rule these out because we can find them on cantaloupes. We can find them on some of these crops, not necessarily that they're feeding. At least we know they come in and out. And then there's the slight, and it's kind of hard to say which way they go in the slight. And there's another important one, cotton, sunflowers, and some of the other leguminous type crops. So again, a start at trying to identify what host can actually, which plants, species can actually host this, so to help us bridge the gap.
John, what are they oviposited on? Have they done that yet?
They'll oviposit on the plant, though. We get a lot of them ovipositing on the screen up here, and then they'll actually oviposit in the soil. In the field, we found them mainly on the plant, but we haven't really done it on the soil. So that's some of the host plants. But I go back to this question about where are they going to spend all summer long? In 2 weeks, or 2 months, when the seed crops are gone, brassica seed crops, how are they going to bridge that gap from right now until next September when all the cold crops start being flushed again? I think initially we need to start looking at wheat. There were some observations that they were observed on wheat last year. Certainly Sudan grass, as it fit into that high category. This may be an important factor. Anecdotally, I saw some heavily infested broccoli fields this spring, this last fall in the Yuma Valley that were adjacent to Sudan grasses fields that had just been cut. Totally anecdotally, but it kind of makes sense. Certainly cotton, I've swept them on cotton. Many of you as PCAs have swept these things in cotton throughout the summer. Whether it can be a reproductive host for them or it can sustain them for a period of time, not really sure. But nonetheless, we know that they grow there at least to some extent in the summer. Alfalfa's another one. I've had reports of people sweeping in on alfalfa. I have found them on the experiment station on alfalfa. How good of a host will sustain for long periods of time? Don't know. Okay, one of those things we don't know. Certainly weeds are going to be real critical. This was taken over in Imperial Valley last year. This was in Imperial Valley. This is a Russian thistle, among other weeds. And you cut that Russian thistle weed over, and they're just massed. This was the end of July. It was just massed underneath these things.
Was that a spray kill, or is that just? No,
That's just a mass of them. We just took a shovel and kicked the Russian thistle plant over, and it was just massed underneath it. Shade, moisture, what have you. We don't think they were feeding on it. You can't see the damage on it. And there are other things we saw. We saw them on citrus. We saw them on some citrus trees pretty heavily. So there are hosts out there that are obviously helping them bridge the gap from the spring until the following fall. We just don't know exactly what that is yet. And we've got studies set up right now. We're doing that right now to try to track that.
John, we've seen one Bermuda too.
Bermuda grass is a good one, yeah. Just sweep nets, sweeping Bermuda, and the net's just full of Bagrada adults. And again, that falls into that grass category.